So summation notation now is the word we're using whenever you say the word series. Now, the notation is different. It is the capital Greek letter for sigma, which is series. Down here, this is the starting value. The notation itself, the symbol is called sigma. And the top piece N is where you stop. Now, when you're talking about these, the K, kind of think of the K as kind of a placeholder variable. You're not going to go ahead and see it at the final product. But inside here, A of K, this is the piece, and this will always be your explicit formula for a summation. And what this says in means and words is to find the sum of all the terms from the start value to the stop value. Or in this case, the start value would be 1, the stop value n. So let's go ahead and look at an example and see what this means. So the question would be written as find the sum when k is equal to 2 to 5 of 3k. All right, so start value, we start when k is equal to 2, so that's 3 times 2. The next value, I go up 1, so I start at 2. The next value is 3, so that would be 3 times 3. Then the next value is 4, so that is 3 times 4, and then finally 3 times 5. So what does this mean? This means that this is the second term, the third term, the fourth term, excuse me, that should be 8 of the fourth, and finally the fifth term. So I add all of those together. That just gives me 6 plus 9 plus 12 plus 20. So the summation is equal to 42. All right, so let's go ahead and look at another one of these. So for the next one, I want to go ahead and look at the summation from k is equal to 3 to 6 of 1 plus k squared. All right, so what I want to have here, so this would equal my third term, which would be 1 plus 3 squared, plus the fourth term, which is 1 plus 4 squared, plus the fifth term, which is 1 plus 5 squared, and the last one, which is 1 plus 6 squared. So that is just 10 plus 17 plus 26 plus 37. So the summation is equal to 90. So the next thing we're going to go ahead and look at today is how to write the explicit rule in Wite and Sigma notation. And this part is really all about recognizing patterns. So if I go ahead and give us the series 0, 3, 8, 15, 24, and 35. Then those values that I have here, this is A1, A2, A3, A4, A5, and A6. So I know I can go ahead and start with my sigma notation. I know I'm going all the way from k is equal to 1 to n. Now, again, variables, it's kind of strange, but this k, that k could be any letter. You just want to make sure you always end at n. But in this case, I only have 6 terms, so I don't want the whole thing. I want that to go from k1 to 6. You do not want to use n to start with. N is, well, the variable n will always be the ending piece. Now, let's look at this. It's really close to that power sequence we talked about before, right? But it's not. But if it was, the power sequence is 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and keeps going. But it's very similar to the one that we did last time. Each of these numbers is just 1 away from this power series. So with this, keep this in your back of your mind. Same thing with even and odd numbers that we did when we were talking about different important series. Even odd numbers in the power sequence are really important because that gives us a way to relate to these, because all of these are just 1 less. So this formula is just k squared minus 1. And that would be the answer for this question. Now, there is no magic way to always do this. It's about pattern recognition. So the more you practice these, the better you will get. Let me just make that smaller. All right, so the next set of numbers we'll look at is fractions. And the fractions are important for us to talk about because I want you to recognize when we're doing these, we have to kind of look for the pattern of the numerator and denominator together and separate. So again, this time I have A1, A2, A3, A4, and A5. So that means my sigma notation is going to go from k is equal to 1 to 5. And if I look at my numerator, 1, 2, 3, 4, 5, it matches what I have in the denominator. It's nice and convenient because that just tells me the numerator will be, hold on. It just tells me my numerator is going to be n. Now, if I look at my denominator is always 1 more than my numerator. So that tells me my denominator is n plus 1. So with these, writing the explicit rule, it's about pattern recognition. Always keep in mind power sequences, even and odd numbers. It will help you with those. In the next 2 sections in this chapter, we'll talk about very specific ones that have a method to find, and those are called arithmetic and geometric sequences and series. And that will be the next 2 sections.